Hi, welcome back. This is another session of Drawing with Joe. I'm Joe, and today we're going to be looking at some cylindrical surfaces. So, cylindrical surfaces in everyday life, well, we're surrounded by them. We see them all the time, and they're, everything from pillars to drinking cans to a flashlight. Not the pyramids, though. Nope, not those guys. How about car wheels? Car wheels are all around us. We use them every day. Those are a cylindrical surface. We've got this guy. And if we look at the shadow, we can see that shadow right there. It's a rough shape, but still you get the idea. That shadow outlines that. We're just using that illuminated box theory. Now if we took it and traced just this part, see, now we're getting the idea of how this looks. Now that's pretty simple. So from front view to side view and top view, we're gonna get pretty much the same turnout. So that's pretty neat. Now what can we learn from this little guy, why I have him out, is look at that shadow right there. That shadow, as we pull it away, we're getting a nice little curvature. So that's a handy little trick when we're trying to make a curve. Use something that might have about the same curve. Alright, so what else do we need to know about our cylinders? Well, we have positive cylinders like this guy. He's a full cylinder, solid, right? And then we have our positive cylinder, this tape, but it's got a hole in it, so that's a negative cylinder, like what a drill would pass through. So when we're drawing this, we'd want to take into account how wide it is, right? And what's going to help with that is having our center lines and our width lines, how far it is from the edge, how our diameter. So there's a lot of things that go into the thought of producing this and taking it from paper to building. All right. So what else? Well, we have got filleted corners. So what's a filleted corner, you ask? Well, a fillet is when we've got a curve that comes off straight. So that's a filleted corner. Notice there's no hard shapes to that. And it's not going to show any lines that intersect. Now, when I say intersect, I mean take a hard bend, like this takes a hard bend there. Okay? And how about a cylindrical intersection? Well, that's pretty much the opposite of a filleted corner. So I'm going to use the same device, but get a little different idea from it here. So if this is the object, this would be our cylindrical intersection. And notice we've got two lines that will show up. Now this would be a side view, and a top view you would have two lines. All right. Now, a transition. And transition is like a double filleted corner. Let's start up here. Except for this, let's see. So our transition would go from here down to here. Okay, it's this area. It has a radius going out from here to here, and then a radii from here to here. So that's a transition. Now there are no intersecting lines with this, and it's great to go ahead and mark these radii so we can get an idea of what the measurements would be when it goes to production. Now a cylindrical curve is just a more extreme transition, but it still doesn't have any. So let's see if we can make a little cylindrical curve. This a little more intense. So if we go from here to here, this being the product, this is our cylindrical curve. Now notice it's just a lot more exaggerated idea of this, with our radii being out here, going out, and here coming. Alright, so what we're going to focus on today, as far as taking it into 3D, is this simple item. Notice we have, and I am going to switch to pencil, and this is in our 3 view, top, front, and right. We do have a hole. Notice the cutaways, and here we've got a center marking. We don't have measurements, but it is on a chart, so we could say each one of these is a 1/4 inch, so on and so forth. And here we've got our cutaways and our center line marking of that hole. Very important. We need to have all those here and there. Here's our alignment. So let's get drawing.